like, in the curriculum in that Python section was going through this as well, just like general tips as to how to approach these problems. So what do we have? We say, okay, power users are those users who bought at least 10 products. So we want for each user the day they became a power user. So when did they buy the 10th item? So it's like, kind of step one is if you were going to do this, right, like by hand effectively, like how would you do this? So here right now we're like selecting all from users. We would order by the user ID, like as just a first step so I could kind of answer the question. And then let's say we select the first 20. But let's do it the right way. We say limit 20. Okay. When did user 1 become a power user? When did they become a power user? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is when the first user became a power user, was 2015, October 21st at 6:20. How did I know that, right? So we counted, right, by the user ID. So again, it's like answer the question, right? Have your brain answer the question. So our brain answered the question. Then the next step is for us to figure out how did our brain answer the question. And it seemed like what we did was we basically counted, right? We ordered by the user, we grouped this user, and then we counted. And then the next thing we could do perhaps is just, I guess we could take it from there, like maybe filter based on somehow this. So, okay, so that's kind of step one is, how did our brain answer the question, right? Just provide an answer by hand or, right? And then unpack how we answered the question. Okay, so what we basically did was we numbered these 1 through 10, grouping by the user. And then from there, maybe we can just filter by that 10th result. So the other kind of advice I generally give is produce the data structure, produce the format of the data that you want to make the question easier to answer. So in other words, it would be a lot easier, I think, if we were numbering these in order of the date, right? In, it seems like ascending order. And we just have a number, right, for each one. And I think we can do that. This seems like a window function to me. Right, if I have a number running, like a new column that has 1 through 10 for each user, this way we can see when their 10th event was. And then we can just go from there. So this would be select the user ID, the date, and then let's say probably the rank, I guess, is fine. I think that's fine. Rank over partition by when do we want to restart, right, the count. That would be with each user ID. Order by the date, ascending, right? We want to go from the earliest is the first event up, and then we'll call this as, let's say event number, something like that. From users, order by user ID, and we'll do limit 20 just so we can see the results. All right, so this is my first user, and we can see this is the 10th event. It's the one that we saw before. Now we're on to the second user, right? And we can think of this guy's 10th event. He didn't have one, but maybe, do we start at 1? Yeah, right? It's good that we're taking this into steps. We're viewing our result. And this way, I wasn't sure, did we start at 1 or did we start at 0? In which case we want to select on 9. But we're making it visual, so we get to really check our work along the way. So now from here, we should all, if we have this, right, the next thing we could do is probably make this our table, right? How do we do that? Well, either with the subquery or with the CTE. Let's just do it with the CTE. So with, let's say, numbered events as, let's say numbered user events as, and then do the parentheses, and then put this here, right? And I always like to do just select all from the CTE that we just created, just to make sure it's working. Okay, so we just wrapped this in a CTE, and now what can we do? We'll just select all from this table where event number equals 10, right? And that should give me the 10th. This is the day of the 10th user event. 2015, 1021, 6/2014, right? And the other one is 2015, 1029. Okay? And now it's like, okay, we need to get into exactly this format, but that shouldn't be so bad, right? We just reduce the columns. Select the user ID and the date, and we're good. Okay, so what was like our techniques? Like we did it by hand, right? We just looked at the data, answered the question, figured out kind of like how we were answering the question, and then like this is like the key thing. I think this often helps is, okay, how can you format this data to make it easier, right? Do that, and then try to answer the question. All right, because once we numbered it, well, then it became pretty easy. All right, questions about this? No? Okay. I would say like same exact technique for the Python stuff. So here's this Python interview prompt. Okay, we have a list of numbers, and we want to produce this output. In other words, I think the problem is we only want to include our repeats, right? And we want to have like the indices where these numbers repeat. So this 212444 thing repeats here, 2, 3, 4, and here, which is this 0, 1, 2, 3, 4, 5. So it repeats here and here, and then this guy repeats here. Oh, it repeats at 2 and 3. No. 1, 0, 1, 2, 3, 4. So it repeats at 2 and 4. Okay. So again, it's like, how would your brain answer this question? Right? I think what you would do is you would create a pile for each of the numbers, and probably like having the pile up front would be useful. So if I had like, like I give the example in the readings of this is like playing cards, where we have like, a slot or like a pile for each playing card, an ace, 2, 3, 4. It's the same thing here. And then what we can do is, store, I guess, the position of each one of these numbers when we see it. I'm sorry, I'm being a little unclear. But for the pile thing, how would we have a pile for each one of these numbers? What you can do, I think, is you can just take a set of the numbers. So now these are all the numbers we'll ever encounter, right? And then let's create, if we want, we can make it, we call these my unique numbers. And then let's say for unique number, in unique numbers, we can maybe create, we can have like unique number, and then like a place to store the indices. And did I break it? Yes, this is fine. Right, so these are my unique numbers, and then like a slot to store the indices. And as you probably guessed, we can also just do dictionary comprehension for this if I'm right and I'm not right, because we need to do a colon here. Right, so the key and then the value. So go through the unique numbers, make each unique number a key, and just store a value. And this, lots of times I call this my skeleton, right? It's like a placeholder, it's like a cabinet. And now we need to just start filling the cabinet with data. Okay? So how do we do that? Well, can you, basically you want to go one by one. What if we went one by one through these digits, and for each digit, right, for each of these numbers, we add the index. Okay, so for this one, we would go here and have an index of 0. Then we get to the next number, and we have an index, and we put the index of 1 into this slot. Then we go to the next number, put the index of 2 into this slot, right? That would be, I think, the next step, for me at least. So I can say for number in numbers, take the skeleton, and that's probably a better word for this, and then the number, right? Because that's the key. And then dot append, and I want to append the index here. So, I mean, the first thought might be, remember, you can do like numbers dot index, but this isn't going to work. I don't think. Maybe it will. See if I do numbers dot index of something like this. I'm concerned because what happens when there's 2? Does this produce both these numbers? I don't know. It doesn't. It only produces the first one. So that's not a good solution. So instead what we can do is, you may have remembered the like enumerate clause. We've seen this before. I think what it does, let's print index comma number. So we'll go through the numbers, and this will, I think, give you the index, kind of give you a pair of the index and that number as you iterate through them. All right, so that works well. So it's 0, and then this 3, 3, 2, 1, and then 1, and then this 2, 1, 5. And now we should be good, right? Because we have this initial skeleton thing that has our that has this dictionary, right? It's kind of like our cabinet, right? Our piles that we were describing, and the place to put the index. And we can go through each number, get the, have the key that will give me the corresponding list to then append in the index. Okay, so for each number in the list of numbers, select the key value pair and add in the index that you're on. Okay, and we can see, like, how close are we? Pretty close, right? Because we have the right answer here, but we also have some extra stuff. Okay, so now we just have a filtering problem. So, right, because we just want to get rid of this key value pair and this key value pair, and then we're left with only the duplicates. So that's fine. So we can say 4k comma v in skeleton dot items include the kv, right? K colon v if the value is greater than 1, right? Because the value is this list. Or sorry, the length of the value is greater than 1. This is my solution. Like, I don't, but I like, the main thing is the approach, I think, is what I do really recommend trying to follow this approach, or at least using this as an initial kind of approach. You can always tweak it to make it your own, but give it a shot where it's like, okay, what's the answer to the question, right? Like, what are the duplicates and what are their indices? All right, cool. So I'm able to answer that. Now, how does my brain kind of do that? Or like, how would I do this if I had playing cards or whatever? How to do this if I forget about code? Right. Create, separate piles for each of these unique numbers, just like we would if we had playing cards, and then go through the cards one by one and put them into their respective pile. So here we create the separate piles, and then we go through it one by one. Instead of putting the card in there, we put the index in there. And now we have too many piles, so just get rid of them, get rid of them. Okay, notice I'm really not thinking about efficiency or, like how many lines of code I'm doing. I'm just thinking about doing something that makes logical sense. From there, you can clean up your code. But even with something like this, where it's pretty short, I mean, I think it's pretty clear, and that's the main thing.
Hey Jeff, so if this is going to come up on an interview question, are they going to be, is it going to be negative that you did like three or four loops to do this? Or like, do they
Not,
care about that
well,
kind of
first of
thing?
all, this isn't. So I did do three loops. We can talk about like Big O later, but this is not n cubed. Like for those of you, this is not inefficient. Let me put it that way, right? What to worry about from a time like something that would take too long is nested loops. And like I said, we can talk about that later on. But yeah, this does not. This is not inefficient code. So they would. This is was big O of n, which is fine. It's great. If it was like n cubed, then yeah, it's like produce the result, and then from there they may say, hey, let's think of some ways to clean this up. All right, to make this less costly from a time complexity standpoint. So it goes back to like kind of our thing is like make it work, make it right, make it fast. Okay, and I can just like I've watched like Google engineers talk about uh like their approach for the interview, like recount their interviews for getting into Google, and they're like, yeah, we always started off with like the inefficient route, what we'll call like the brute force mechanism, right? Which is just like the most generic kind of inefficient way to approach a problem. The reason why you do it that way is you solve it, your brain starts to digest the problem, right? Like and it's answering the question, so you are making progress, right? And then you can worry about refactoring it and give yourself time to think through the problem, right? Like I think when I did the technical interview with you all to get into the course, I said that to a lot of you as well, is like talk out loud, tell me how you're solving the problem, because then I can as the interviewer, you can always correct the problem solving technique and work with you, and that's what they'll probably do. But if you're just coding quietly, like in generally what happens is you get nervous about, and you just want to answer. The real question you want to answer isn't like find the unique numbers. The real question you want to answer is, can I pass this interview? And so you just try to answer that question as fast as possible. But you just try to like pretend this is just like a brain teaser. No one's watching, right? Or it's not for anything. And be curious about it and stay in the problem, and it will be, it should work out better. Like that's what I try to do when I do these, and it's tough, but that's what you aim for. All right. Okay, so we're about at time. For the next class.